Hi, everyone. Welcome to this session with Project Pro on the AI Monetization Podcast, where we specifically talk with industry leaders, flushing out enterprise use cases being implemented using AI, specifically GenAI. Today, we have with us Dr. Prakash. Dr. Prakash is a principal and partner at ZS. ZS is obviously the world's preeminent consulting firm focused on life sciences and healthcare. And practically every large life sciences company in the world is a client of ZS. At ZS, Prakash leads the AI Innovation Lab, where he just told me that they recently published a paper in the prestigious Nature publication. Prakash has not one but two PhDs, one from the University of Wisconsin-Madison and the another from the University of Warwick, and where he actually started a analytics startup as a PhD student, and one of the earliest analytics startup in 2010. Uh, Dr. Prakash, thanks for taking time to do this. Welcome.
Thank you. Thanks, Binny. Thanks for inviting me.
Perfect. Uh, so, Prakash, to begin with, right, to many of our listeners who are on the business side of things, a common confusion is what is the difference between business analytics, data science, machine learning, Gen AI, and what problems should be solved by each of these groups of people. Today in my company, all of them sit in the same team called analytics. What should I give to who? Could you help us understand that?
Sure. Yeah, I
Yeah,
can actually maybe I will break it even more because there's a lot of terms floating around.
right.
Of course, there's a business analytics part of it. Then people start talking about data science as a key term. Then there is a
Hmm.
machine learning. Then people started talking about AI. Then
Hmm.
Gen AI.
Hmm.
Within Gen AI, there is a NLP, NLU, NLQ. So there's
Right,
there's a plethora of terms which is
right.
currently sitting in the market.
Hmm.
Now, when we talk about okay, so the broader bucket we actually talk about is the AI. Maybe we'll start with that and then narrow it down slowly.
Yeah.
So the AI really is where we are making machine to think like a human. That's which basically the key objective is. So there is a
Hmm.
cognitive element to it associated with. When we go to the machine learning, which become a subset of the AI, which where we are trying to feed the data to the machine to learn patterns automatically
Hmm.
without any human intervention. That's where the machine learning element comes into picture. When we talk about data science, it can be statistics or anything else where we are trying to crunch the data to derive an insight overall. Now, that's where I think the DS data science part comes into picture. Uh, whereas when we talk about business analytics, I think it's a lot to do with how we crunch the number ingest the domain and come up with an insight out of it. So it
Hmm.
maybe sits within data science as an element. So there is much broader element to it where the data science brings statistics, algorithms all together in a system. Now within Gen AI part, actually again sit within one of the key element within machine learning where the focus is on the generation part of it. So when we look at the machine learning as an element, there is two ways you can define it. There is a discriminative way of solving the problem, and there is a
Hmm.
generative way of solving the problem. When we think about discriminative, you're trying to have a response XYZ, you build a linear regression kind of model, get an estimate, fix the model part of it. Where generative is more stochastic, depending on what has happened as a next token, you're trying to predict the next token, where next token itself depends on the context and there is stochasticity to the process. So generative is not a new theme overall. I mean, it used to be happen before from a simulation perspective in a system. Now with the understanding of the language become much bigger, and that's where the whole theme is becoming broader and broader. Now,
Hmm.
if you want to further break AI in some of these things, the AI really started with a lot of narrow AI part of it, like Netflix has
Hmm.
a movie recommendation engines, all
Yeah.
part of it, right? You have a dynamic pricing related use cases. So we actually try to solve for a very, very specific use case. A page ranking algorithm which Google have is
Mhm.
all fall into the narrow UI where the use
Mhm.
case is very well defined.
Yeah.
Then it's now moving toward a general intelligence part of it, and
Mhm.
lot of your model like OpenAI uh,
Mhm.
uh, is going toward that where they have a one specific AI model which can have a NLU, natural language understanding capability. So it can understand what you are saying and can
Mhm.
provide you response based on it. So it can be used much more horizontal rather
Yeah.
than for one specific use case. Now the
Mhm.
next level is going to be more in a super intelligence part of it,
Mhm.
where I
Mhm.
think all these systems are going to behave
Mhm.
like a human and can do tasks which is involve more physical as well as language part of it, and that's where
Yeah.
the lot of this research is going on. Where all, if you think about it, all things are coming together. You have vision, you have
Mhm.
audio, you have
Mhm.
smell, sensing coming
Mhm.
in, all the language understanding coming. If you combine them together, you will
Mhm.
start forming all your six senses in some way.
Fascinating. Uh, yeah. And you specifically mentioned the Netflix recommendation engine, right? So that's a very interesting example because it's a classic traditional ML problem use case as well. But it also seems as if the same problem can be solved using GenAI as well. Um, from a user or from a business outcome, what is the difference solving a recommendation problem using a traditional ML algorithm or a GPT-4? What's the difference?
Correct. So the if I take an example from a Netflix historical, I mean
Yeah.
that's the intention really they start building with the metrics factorization. That's where I think they really started
Mm,
the whole thing. Where the intention is can as depending on what you have seen before, what you have liked, disliked, can I tell you
mm,
what really the movie you are going to like, right?
mm,
So here the focus is really on narrow task. Give me this movie.
mm,
Now think about a Gen AI era where
mm,
now I can definitely know, but when you have clicked the movie, what is the tile? What is the image which is sitting on the movie? And I can really create contents
mm,
dynamically because that's where a lot of these things are going. The trailers are going to be customized at a
mhm,
user level. So
mhm,
I know you are going to watch this movie because you prefer a specific type of sequences, and if you see that, you basically click and high likely to watch the movie as part of
mm,
it. So content generation become very, very important. So all
mhm,
this new element around Sora, for
mm.
example, which has been released, which can actually start doing a lot of this generation
Yeah,
of video generation. Lot of this is going to come. Image generation, image recommendation is becoming important. For example, I think there is one work which we have done where we are dynamically changing the images
yeah,
depending on the user who is landing on a website, and that
yeah.
actually lead to much higher click-through rate for that
Right,
particular website.
right. Okay, that's very interesting. So just to make sure I understood this, Prakash, so you were saying that the difference between using a traditional ML algo versus a GPT-4 for a recommendation problem is that in the traditional ML way, that would probably take us inputs fairly structured data based on my previous preferences in terms of
Correct.
what I watched. But whereas using a Gen AI model, it could actually take in unstructured data like the sequence of frames in a trailer I
Frame.
like. Based on that,
Correct.
it will, which otherwise you really can't store a sequence of frames in a database
Correct.
to learn from that, right?
Correct. And plus, I
Very
think
interesting.
some of these content generation are becoming much, much advanced in the
Right.
terms that they can actually start creating. And I will give you one of my personal examples.
Yeah.
When my daughter was small, I used to
Mm.
tell stories, right, through
Mm.
books.
Right.
Uh, Now, with my son is small, I actually tell a story, but at the same time, I create images for that story. So I
I see.
create
Yeah.
dynamically
Right.
because now he become a habituated that when I even want to tell him a story, he
Yeah.
want images for it. So more
Interesting.
dynamic. So
Right. Right.
the way information is being consumed and
Yeah.
actually passed is also evolving.
Yeah. Yeah. No, I have a 5-year-old daughter as well. And, these days, whenever she wants a story, she picks up the GPT-4 app on the phone and
Correct.
she'll basically instruct it saying, I am a 5-year-old. Tell me a Supandi story with
Exactly.
me in the story. Uh, and it'll give out some very, very interesting stuff.
Exactly.
Yeah, yeah. Okay. So, so inside a company, once business leader has decided, okay, this is the problem I want to solve using Gen AI, there's a bucket of problems. How do I select a problem by maximizing the probability that it will go to deployment?
Correct.
That it's not some POC, it will be sit there. What kind of problems have you seen are most likely to get deployed?
Correct. Okay. No, sure. So,
Yeah.
the when we actually look about Gen AI as a use
Mm,
case, I will also
mm,
maybe go a little bit more horizontal in this.
sure.
As of now,
Mm,
where the industry really stay, I would say
mm,
we are still starting, right? Most of
mm,
the things I define into three different waves, which is going to come. The first
mm,
one is a fast Gen AI.
mm,
So that because people really want to show the value of the Gen AI,
mm,
and they are trying to go for use cases which are very productivity driven
mm,
in a systems, right?
mhm,
Uh, and which can be how can I consume the information? I
mhm,
have a lot of SOPs sitting out there. I want to
mhm,
query that part. Can you build
mhm,
a chatbot for HR systems, for example, right? So it's more focus on consumption part
mhm,
of it. As part of it is which basically very quick
mhm,
from some setup, but again, I mean there is a risk associated with a lot of these applications, so people need to understand both the dimension,
mhm,
but mostly focus on fast Gen AI part of
mhm,
it, where how quickly we can deploy. The
mhm,
second level of Gen
mhm,
AI, which is going to come mostly, is a deeper
mhm,
Gen AI,
mhm,
which is not only going to focus on tell me
mhm,
extraction related part of it, but
mhm,
also will involve insight related
mhm,
part of it.
mhm,
So that's where I think they are going to go much more deeper in these use cases.
mhm,
For example, I will one of the systems which we are actually working on is how can I convert a natural language query to insight directly,
mhm,
part of it, and where I think the backend data could be structured or unstructured, doesn't matter, but
mhm.
if can I connect with it, once you ask a question, can I convert that question in the domain context which you have
Yeah,
as part of it, convert that into chain of thoughts. That chain of thought can we convert that into write code
yeah.
in a system, and then can we execute and get the response back, right?
Mhm,
So that's potentially trying to go more deeper
mhm,
in that one. The third one, which is going to be much more what we actually call it, going to go more horizontal or
mhm,
transformative Gen
mhm,
AI part of it, where the
mhm,
intention is not only go deeper but take actions
mhm.
for me. And that's where I think the industry is going to go
Yeah.
slowly
Mhm.
from that perspective. So uh,
Okay.
it's a journey which
Mm,
most of these industries are taking overall.
mhm,
And when they're actually selecting the use cases as of now, I think
mhm.
lot of focus on the fast Gen AI.
Right.
Slowly
Right.
they're moving toward a deeper now.
Right. Yeah, that's actually very well framed. Productivity, reasoning, actions. Usually. Right. And it kind of also reminds me, I think some couple of weeks back, OpenAI's Sam Altman, he made this quote where he said that I wish, today people use ChatGPT more as a database querying this thing. I wish they
Correct.
use it more as a reasoning tool.
Correct.
Uh, Now, since you're in research, right, Prakash, where is the state of the technology today in terms of reasoning? Uh, and
Correct.
where are we headed? What's happening in that place?
Got it. No, fair. Maybe I think let me define how the people used to interact with the system
Okay.
overall, and how it has been evolving.
Yeah.
And maybe some of this is also driven with how why we started some building something like NLQ.
Yeah.
So when uh, the human machine interaction, when I mean it's really started as you go old, I think it's all assembly punch cards,
Hmm.
where people used to be very hard for you to
Yeah.
build something. Compute is also a challenge
Yeah.
for people. Now they felt again to simplify it, people start moving toward a functional programming
Hmm.
in a short, right? So start converting that in function. You get compilers as part of the system, and that's how they started interacting.
Hmm.
Again, they realized that lets a lot of code footprint. How should I reduce it? But then
Right.
they actually went into object-oriented programming
Hmm.
part of it, which actually reduces the code footprint, make it much easier for people to reuse and modularity in the
Yeah.
system.
Hmm.
But at the same time, it's still harder for people to interact with the machines.
Hmm.
So, so it moved toward visual programming, where a
Mm-hmm.
lot of your data IQ, Ultra, there are lot of tools out there which try to, you can now drag and drop, create a flow and then execute the data
Yeah.
side, right? So
Yeah.
really, it simplifies
Mm-hmm.
part of it. But even to do that, people need to understand what to pull, where to pull, what really
Right.
is part of
Right.
it. So the
Right.
next level of evaluation
Mm-hmm.
is actually really going to happen is, can you ask a question, and
Mm-hmm.
the generative AI with their NLU capability understand it, contextualize it,
Mm-hmm.
and then execute it for you and give an outcome.
Yeah.
If that level of interaction can reduce
Mm-hmm.
the dependency on technical side of the whole thing, but at the same time it's going to provide you, or give you much faster way to
Mm-hmm.
interact with your data and
Mm-hmm.
understanding. So maturity is now coming to the maturity part of it. That's where I think the evolution is happening on
Mm-hmm.
lot of these sides
Mm-hmm.
in a system, and it's fairly evolving
Mm-hmm.
as part of it. What we see when it comes to lot of now the way we define the question, there's a how, what, why part of it. It's
Mm-hmm.
very strong when, as you mentioned, right, extraction related question where it can
Mm-hmm.
have to do aggregation part of it. How, what related question, very in
Yeah.
the system. Why is tricky because when you start solving the why question, you need to start infusing domain in these systems. It cannot see LLM knows uh, much more horizontal universe, but
Mm-hmm.
there's a lot of data which sit in enterprise, which is their contextual. If you pick a pharma as an example,
Yeah.
the definition of line of therapy in a real world data changes from one industry to other industry. It's not
Mm-hmm.
consistent. So
Mm-hmm.
if I'm actually asking, or if you're changing from one therapy area to other therapy area, even for same therapy area changing from one industry to other industry.
Mm-hmm.
So one, so that's, so if you're asking a question,
Mm-hmm.
uh, if it doesn't know the context, it will never able to reason it well. Why? The
Right.
answer is so. So that infusion is very important in these
Mm-hmm.
systems. So it's improving that part
Yeah.
from the reasoning perspective, but
Yeah.
in you still have to configure and infuse the domain in this system to make it reason for your scenarios. And that's where when we build this whole system, we
Yeah.
break it down into multiple configurations, which is actually required
Yeah.
part of it, from a
Yeah.
data context, domain context part of it. And that's one
Mm-hmm.
of the secret uh, sauce for when
Mm-hmm.
you actually think about how do you bring that capability and build the repository and configure that repository quickly when you do that deployment for an enterprise setup.
Very interesting. And, and just for my limited understanding, the infusion of context today, is that how we do using RAG, fine tuning, SLMs? Is all that context infusion in a way?
Correct. So you can, exactly. So RAG
Okay.
is again, you are grounding the system to
Mm-hmm.
give you an outcome
Mm-hmm.
overall
Mm-hmm.
in this system. So RAG is
Mm-hmm.
also a context infusing SLM. So the two ways you can SLM, you can do fine tuning, which is
Mm-hmm.
so when people actually do the SFT, which is supervised fine tuning for GenAI,
Mm-hmm.
I mean they are really learning the formats,
Mm-hmm.
how to structure my app rather
Yeah.
than really the data, because the data is never went into the pre-trained part of it, sit in the LoRa metrics
Right.
or QLoRa metrics for you.
Mm-hmm.
But when you do a pre-training in the
Mm-hmm.
system, then you are feeding that information, making that system learn your data, the way it started getting
Mm-hmm.
adjusted in that. So
Mm-hmm.
I mean, it's a model grounding to some degree. So
Mm-hmm.
the way you do a context grounding in the
Mm-hmm.
RAG based framework. So
Mm-hmm.
both are going to evolve. I think as of now, most of the organizations are still
Yeah.
utilizing the RAG base because of the unstructured kind of use cases. But as we go, the data size is increasing. There's a
Yeah.
limitation to
Yeah.
the RAG
Right.
from what it can really do, because I still have to fix the number of chunks. The context length is increasing, but the
Right.
lost in the middle problem still exists.
Correct.
And overall, so you potentially will require both
Mm-hmm.
in some of this with the with the increasing
Mm-hmm.
computational capability, and we are realizing that SLMs or small language models are becoming more and more prominent, and they
Mm-hmm.
are becoming better and better. The people will start using those down the
Mm.
line.
Understood. Okay. You made a very interesting point about for successful deployment. The magic is in correctly configuring the data context and the domain context. Could you maybe help us understand that a little more using a use case? What
Sure.
do you mean by that? Yeah.
Yeah, definitely. So
Yeah.
let's say I I basically want to uh, do a driver analysis for one
Mm,
of the data set, which is a commercial
mm,
data set where I have
mm,
a lot of sales related information setting out there. Then I have information associated with targeting, like how many emails has been done, what has been exposed, what the frequency is, what's the reach is, part of it. Now,
mm,
to do that driver analysis in the
mm,
as part of the system,
mm,
there is a lot of domain which actually sits we need to be introduced as part of it. One of the important consideration is the priority of the
mm,
feature itself. So when we actually look at
mm,
uh, from a recommendation perspective for a
mm,
marketing,
mm,
reach get higher priority. If I see a
mm,
problem with a specific feature associated with the sales, then I
mm,
need to make sure they fix the reach if the reach
mm,
has the problem. If they
mm,
have not reached out, there is no value of the frequency
mm,
itself. And then if they have not reached out, then the engagement anyway, if there's no frequency, then the engagement doesn't become an important variable for
mm,
you. So when we actually do the driver analysis, there has
mm,
been model or feature prioritization has to be taken place
mm,
overall from an adjustment perspective. So how do you incorporate as part
mm,
of the even the model part in the
mm,
system
mm,
overall? Now there is a lot of horizontal dependency in terms of temporal dependency. For example, if you're actually building
mm,
any of these marketing mix kind of model,
mm,
one of the important part is there is a memory effect with sets, which
mm,
is the ad stock part of
mm,
it. Because if I actually reached you tomorrow, or basically
mm,
if I given a call tomorrow, you will remember me for few days before you forget that
mm,
Prakash has called you.
mm,
So how to basically incorporate those contexts in
mm,
this system, right? So those are contextual
mm,
information or domain contextual information that has to be incorporated as part of the driver analysis.
mm,
Now, the second important component is the
mm,
data context, which
mm,
is when I basically in a system, my column name really is a, let's say, is a new RX
mm,
as part of it. But as a business user, I always call it a sales.
mm,
So I will just actually ask, okay, tell me the driver for the sales in a system, but the system should automatically realize sales is
mm,
referring to the new RX uh,
mm,
for me. So that's the data context part of it, which is actually a lot of how you can pass the column name description associated with it, or connect
mm,
with your catalog, data catalog in a backend where you can pull the right information
mm,
for you. So that's the
mm,
second part of the thing.
mm,
So that has to be also told to the system either as part of the prompt
mm,
overall,
mm,
or as part of the examples in
mm,
a system, or
mm,
as part of the custom functions in the
mm,
system.
mm,
So there is a multiple ways you can expose, right? I can expose it as a definition, I can expose as an example, or I can
mm,
expose as a custom function which I have built. For example, driver analysis, we build our own custom function. Three reasons. One, it
mm,
it reduces my output token
mhm,
automatically because
mhm,
I'm using LLM for orchestration. I'm not
mhm,
using LLM for generation
mhm,
in a system. That's
mhm,
second. It
mhm,
actually introduce. It basically is make my system more reproducible. Because
mhm,
if I am asked every time it has to generate the code,
mhm,
it's going to be it may sometimes be sklearn, for example,
mm,
as a package to build the linear regression model, or sometimes it builds some other third party regression model to build the linear regression, or sometimes custom wrote the whole thing. So there is the reproducibility is one of the key challenges which
mhm,
actually sits with the LLMs. So it will
mhm.
make the system reproducible because I am first priority is pick my function.
Yeah.
If it is not there, then
Mm,
go for generation comes
okay.
into picture. The third advantage,
Mm,
tokens are less, the
mhm,
cost is lower, at the
mm,
same time latency is lower.
Mm.
for the generation. Because one of the important thing, which is also important when it comes to the Gen AI part, is the
Mhm.
latency element,
Yeah.
and that's where the streaming is a very very smart thing which OpenAI has done. But as you go to more complex use cases,
Mhm.
this latency is not going to come down. And user, from a consumer or user perspective, as soon as anything goes above 3 seconds,
Yeah.
it's slow.
Right.
But
Right.
if you're parsing a data which is million records,
Mhm.
then I mean you will still expect some compute effort to be going in. So
Right.
how do you make sure the user are still engaged with the system? So
Right.
latency is another very very critical element.
Mhm. This is very, very helpful. Could you just help us understand a little more? What is a custom function?
I see. Okay.
Yeah.
So
Ah.
so custom function or the byte function is
Mhm.
something which has been written
Mm.
and kept already
Mm.
as a repository. So
Mhm.
it's something, for example, you build a driver analysis function in a
Mhm.
system. So you
Mhm.
have a definition or class already written to do a driver analysis. What you really need is input
Yeah.
for that driver analysis. So the
Understood.
LLM understand your query,
Mm.
identify the input,
Mhm.
call my function by passing that input and execute it in a backend.
Understood. Got it. Okay. So we have covered, the difference between business analytics to Gen AI spectrum. How do you pick the right use cases for deployment? And the magic sauce behind the data context and the domain context. Um, now, now I'm at a point where I'm ready to build my first use case out. What does my tech stack look like? Do I use my same Snowflake, the data warehouse? Do I need a vector database? There is a zillion foundation models. How should I think about each,
Correct.
I guess, component of this life cycle?
Correct. I think, well, there's a lot of consideration when we
Yeah.
actually pick the tech stack. And again, it also depends on the kind of use cases which
Mm.
we are trying to build
Yeah.
for the system. Maybe I
Hmm.
can pick the use case more from a perspective of RAG, which is a
Please.
Q&A, which is very, very standard use case,
Hmm.
which has been used at a lot of places. For most
Hmm.
of the Q&A system, RAG is fairly important use case.
Yeah.
Now, there also that first, even before you take a call, I think we need to understand the complexity and usage of it.
Hmm.
That's the first level of,
Hmm.
of the setup. And the reason to make that understanding is, should I really need to build a custom, or can I something which exists? Because when it comes to the RAG, kind
Hmm.
of, I think a lot of offering exists in the market. If you go to Copilot Studio, you go to GPT Enterprise part of it in a system, or you basically Google has a RAG system overall. So almost everywhere there is something which exists which can be configured
Hmm.
to the system. Of course, there is a limitation for a low code, no code scenario. So that's where the complexity of the use case is very, very important to understand as part of it. If you go to a custom route part of the setup,
Hmm.
then I think the intention really become picking. If you need to build the front end
Hmm.
as a custom part
Hmm.
of it, or again you want to leverage. Now again, there is a lot of platform itself. There's the Mendix, which is low code front-end development part of it, or you can start using custom React-based framework to start developing your front end in the
Hmm.
system, right? So that's where I think it become a very, very important setup. Now, then there would be a back-end element associated with it, what you really
Hmm.
want to utilize, where
Hmm.
how you publish the solution
Hmm.
itself, and the lot of time the as of now, most of the backend is still Python
Hmm.
based setup with a fast API is been used to build as a lot of REST API. Some of the application may require a socket as development with the streaming, give you a
Hmm.
little bit more control on those systems, but you end
Hmm.
up picking a setup part of it. In case of RAG use case, now you have to start understanding the scale of the RAG use case. For example, I think for one of the uh, implementation which we are actually doing, I think there are more than 1 million documents sitting out there.
Hmm.
So although we talk about RAG as the pain point,
Hmm.
that's not the pain point in this case. The pain point was digitization, which is the conventional
Hmm.
problem.
Yeah.
because how do you really digitize a million document at speed?
Mm-hmm.
And that document is continuously going to come and increase for you. So
Mm-hmm.
how should I scale up
Mm-hmm.
and basically create a digitization mechanism,
Mm-hmm.
get the data, pre-process the data, get and then that convert that into chunks and then store into the embedding. And
Yeah.
in general, when we think about RAG as a system for a scalability,
Mm-hmm.
I think the bottleneck is digitization. Retrieval is very fast. In general, I mean, if we go with the FAS kind of retrieval base, even very, very simple,
Mm-hmm.
I think it takes milliseconds to retrieve information from millions of documents. So
Mm-hmm.
retrieval is not the bottleneck in the system; it's the digitization. Because if and that's where a lot of time when people actually given access of document to the user
Mm-hmm.
that you upload the document, I think the lot of latency really come from a digitization. So if you
Mm-hmm.
basically bring, and that's a design choice, right? For some of these use cases, I can make the digitization offline. Some of the
Yeah.
design choice, I have to make it online depending on what capability I want to give. But at the
Yeah.
same time, I need to make it async from the
Mm-hmm.
user consumption persona, so that they don't start feeling uh, that it's not working or just hang or there's a white screen coming out on my front of it. So
Right.
that's very very important that how you think about the design, because it's consumer and consumer you cannot control the behavior for a
Correct.
consumer. So a lot
Yeah.
of the back-end thinking really come
Yeah.
from the consumer behavior side of it. Then of course it comes to the picking the right database in the system, and there's a lot of options. There's commercial options like Pinecone sitting out there. There is open source options. If you have a small data set like ChromaDB, you can use PG Vector, you can use Redis. If you want to keep in a cache, so if you want to gain more latency, but that compromises with the cost for
Mm-hmm.
you. So there is a different pros and cons for different systems at the end of
Mm-hmm.
the day. So that's another key choice. I think for scaled ecosystem where the
Mm-hmm.
latency is a very very key to us, we go with the in memory database like Redis for example. But
Mm-hmm.
again, I mean, it depends on the cost implications, how you basically balance the whole part
Yeah.
overall. But that's the another important element for it. And then the third part really depend is choice of model.
Mm.
Because once I get
Right.
the chance, I need to create that prompt and send it out, the prompt
Yeah.
in the system.
Yeah.
And again, that also depends on the load for you.
Mm.
Let's say, because as of now, most of these have a throttling introduced from their side, which also means if I have
Mm-hmm.
a lot of consumer hitting
Yeah.
at the same time at a higher
Mm-hmm.
concurrency in the
Mm-hmm.
system,
Yeah.
it will fail,
Mm-hmm.
and it will time out in the
Yeah.
system, and you will not get a
Yeah.
response back, which is the bad
Right.
customer experience. So the
Right.
multiplexing is could be another way where I can start fluctuating between, if there is a higher load, I
Mm.
may reduce the quality of it, but
Mm-hmm.
I start hitting 3.5 instead of 4,
Mm-hmm.
for example, right? So that you can actually start going. That's one element of
Mm-hmm.
utilizing the multiplexing in these
Mm-hmm.
designs. The other element is the cost element to it,
Mm-hmm.
and that's where the orchestrator sit overall. Where if the quotient is very very standard,
Mm-hmm.
and cache
Mm-hmm.
sits as part of it. So, for example, if you ask, tell me about ZS
Mm-hmm.
overall, or basically, and that question is asked by 7 different people,
Mm-hmm.
or as an organization, then do I really need to generate it every time, or can I just reuse the element
Right.
itself? So reusability of, or you came and you re-ask the question every time, but
Yeah.
the data has not refreshed. Should I
Yeah.
really call that? If there
Yeah.
is no refresh in the data, and you have given a higher information, it automatically gets captured as part of it.
Mm-hmm.
So that's the another key element as part of it is the cache,
Yeah.
which got built in these systems to
Yeah.
basically improve the performance or latency
Mm-hmm.
as an outcome. And then evaluation part of it. And again, there's a lot of framework which actually said Ragas is one of the framework which, or True Lens is another framework where actually start evaluating the answer relevancy, question relevancy. If you have a ground truth to, when you are deploying it in a
Mm-hmm.
CI/CD environment, you need to still set up all the unit test cases. How do you evaluate they are
Yeah.
right? If
Mm-hmm.
you make, because some of these are very sensitive, the
Mm-hmm.
prompts response are very very sensitive.
Mm-hmm.
Technically, if you keep the same prompt and they update the model on their side because of
Mm-hmm.
RLHF,
Right.
the output keep changing. They are not
Exactly.
consistent.
Yeah.
So how do you make sure the
Mm.
system is robust enough from an operations perspective? That's another very, very important element that has to be taken into account.
Mhm.
So
Well,
there
that's
there is a
fantastic.
lot of element from a deployment side.
Yeah. That's very nicely covered the entire pipeline. So, one thing that occurred to me when you were explaining this, right? You were, talking about caching, in-memory databases, CI/CD, things like that. A lot of that seems like the kind of work an IT department or a full stack developer would do. So now, if I'm in a company, I'm trying to give this project to somebody. Would I give it to IT plus data engineering, or would I give it to data science plus data engineering, or would I give it to all three people? Like, who would I give this to?
And that's a very, very good question. Well,
Okay.
now and it's important, right? Because
Mhm.
the way
Mm.
and again I may go a little bit back
Yeah,
how the AI used to work, right?
yeah,
So
yeah.
initially,
Mm.
they have been very standard breakdowns.
Mm.
With the way we break down the phases when we actually do,
Mm.
right?
Mm.
They're used to have a POC where you actually prove the concept in
Right.
the system.
Mm.
Then basically that POC goes into pilot where you basically evaluate the concept of this part of it. Then that
Yeah.
pilot really goes into scaling
Mm.
part of it.
Mm.
However, with the GenAI,
Mm.
everything has have consumer facing element to it.
Mm.
Because as of now, it
Mm.
will change, and there are
Mm.
use cases where it's changing.
Yeah.
Where I'm seeing it. There are
Mm.
use cases that uh, getting focused on a different element of it,
Yeah.
but lot of use cases are very consumer centric
Mm.
overall. Because they're
Mm.
consumer centric, lot
Mm.
of element is technology element, that how
Mm.
do I configure the setup, deploy that, because it's going to go into production. Maybe I think that's how the initial AI
Yeah.
was broken down.
Mm.
Now in case of Gen AI, I
Mm.
don't think it's very, very different
Mm.
in the process.
Mm.
However,
Mm.
the elements actually, the way it resurfaces changes from a use case. And maybe I will give you two examples.
Mm.
Let me pick one example where it's a use case which is associated with SOP harmonization. So that, I
Mm.
mean, just to define what really happened is, I mean, all of this have a statement of SOPs to basically for the process to work in as part of it.
Yeah.
Now, you usually they use a global SOP to write
Mm.
a parent SOP, and that
Mm.
parent SOP end up writing a child SOP as a
Mm.
reference, and they
Mm.
end up quoting a lot of these references
Mm.
for them. So the child SOP keep expanding in
Mm.
a system as
Mm.
part of it. So, but really, you can reduce the number as SOP
Yeah.
by bringing them together
Mm.
as an harmonization process, and
Mm.
basically update the parent SOP itself based on the
Mm.
child SOP. Right. So that's the
Mm.
one very, very interesting use case where the, again, if you think it's a fairly standard Gen AI related use case where I can
Mm.
do the digitization, get the information out of it, understand the differences between the parent SOP and the child SOP, and
Yeah.
try to identify how to update the parent
Mm.
SOP.
Mm.
It seems the Gen AI can do it, but it requires a lot of iterations on how to do it in terms of matching
Mm.
sections is
Mm.
important. Identify the right section on both the side,
Mm.
uh, the right chunks on both the side. Then
Mm.
what are the differences associated with it? And then
Mm.
using that differences, how should I frame it out? So
Yeah.
there has been good amount of components for NLP related
Mm.
part of it, digitization related part of it, as well as Gen
Mm.
AI related part of it
Mm.
in this particular use case. So and require a data science kind
Okay.
of persona to
Mm.
still go and do those experimentation and optimize the solution, because
Mm.
there is an element of setting up a demo where I
Mm.
can actually take an example and show that it has a capability to do the things, but
Mm.
how do you make sure it reproducible
Yeah.
overall, and it can scale for n number of documents. So you still
Right.
need to make sure that your prompts are rightly optimized, the flows are rightly optimized, and at the same time,
Mm.
one prompt may not work for the system.
Right.
Ideally, the good practice is you should actually reduce the number of prompts as
Mm.
much as possible, and that's where the agentic workflow is becoming more and more discussed right now, where people are initially saying chaining. but chaining is still not sufficient. You need collaboration
Mm.
in among these agents, which is even bigger framework to address. But
Mm.
that's one
Yeah.
key example, which is totally focused on the Gen AI related. The
Mm.
other use case where
Mm.
one of the other scenario is where we are trying to provide a recommendation to marketer, which is completely business user,
Yeah.
but we have a lot of data which is
Mm.
setting based on the touch points what they have sent and other part of it. Now
Mm.
to even generate that recommendation, I still need a conventional model to be built. So
Mm.
we end up identifying building a model from a uh, to identify the relationship between the uh, sales or engagement index to get which variable is defining. You basically extract them as a shape in a system, then
Mm.
basically put a narration on top of it and convert them in an insight and subsequently capture that into a recommendation. So this is a very good mix of Gen AI and classical AI coming together.
Yeah.
They are not an
Yeah.
independent element. And again,
Mhm.
you require a skill set of a data science here as well. So so what we actually also recognize, there's an element of
Mhm.
all these are required, which is data scientist, where I mean a lot of how do you frame the problem
Mhm.
in the right way, bring the right domain part of it.
Yeah.
Machine learning engineers, which
Mhm.
can be take this solution, further optimize that and engineering it for
Mhm.
the production ready setup.
Yeah.
And
Yeah.
then again, lot of tech requirement from a DevOps, front end, back end, middleware, all those comes to make sure that you have a good optimized and scalable system.
Yeah. Makes sense. All the three teams kind of come together
Correct.
to provide a
It's
solution.
coming. It's becoming more and more prominent actually.
Okay. Now, you and your team recently published a paper on digital twins in the, prestigious Nature, which is probably the top two scientific publications out there. Could you maybe help us understand that use case in a little more detail?
Sure.
Yeah.
So, okay, sure. No, yeah, definitely. I think that's a uh, interesting one because,
Yeah.
of course, people talk a lot about large language model as one of the key things, but the generative AI is a framework which is out there for a long time. For
Mm-hmm.
example, GAN is there, generative adversarial network, which is used for a lot of the synthetic data generation related use cases, another part of it. So
Mm-hmm.
we basically enhanced
Mm-hmm.
something. So let me actually the key use cases which we are actually trying to solve as part of it. How can we create a digital twin for a patient who is on a trial?
Mm-hmm.
Now, just to give you some context, in general, a trial really takes 7 to 10 years of process to go through. And if you are actually dealing with something which are rare diseases as a condition, you will not even find the patient to create a test control group.
Right.
It's so how do you make sure that your trial is going to get successful in these
Mm-hmm.
systems?
Mm-hmm.
So the digital patient on the other side can help you to understand the patient behavior and journey, and can
Mm-hmm.
we project that journey how it's going to happen
Mm-hmm.
uh, to that can be used to understand the behavior part of it. Now the way you can see is there are multiple elements to this problem. There is an so which the GAN kind of framework doesn't solve. One is it need to be personalized because uh, the two different patients, depending on their comorbidities, for example, age part of it, they may have a very different journey, although they look very, very same in
Mm-hmm.
this. So how do I make sure that there is a personalization
Mm-hmm.
element to it? The second part is as you go in lot of this generation in a system, there is a lot of different majors or tests where, which they actually take, right? So those are so this is technically a multivariate
Mm-hmm.
generation
Mm-hmm.
at the same time, not a single variable, because to assess a patient, I need to look at multiple dimensions for them. The third is it's a journey. So
Mm-hmm.
is a time series. So there is a dependency which goes at a one to next level, very, very similar the way language model works. They have a context and then you try to predict the next token
Mm-hmm.
in the system. And the fourth part is the journey itself is not constant for patients. So they terminate in between, right? So there is a termination event which
Yeah.
exists. So it's a very variable length of journey
Mm-hmm.
for them. So how do I include the termination effect how do I include the multi variable part of it? At the same time, how do I include the personalization element as a
Yeah.
condition part? So that's where we actually build something called clinical GAN,
Mm-hmm.
as which actually take a patient, simulate a patient, complete the journey, and we have
Mm-hmm.
applied it to multiple use cases. One of the key use cases where we actually deployed is specifically to predict the patient drop off from the trial,
Mm-hmm.
and we benchmark with the discriminative kind of approaches. Again, there is a benefit of accuracy, but
Mm-hmm.
I think more than accuracy, the
Mm-hmm.
benefit is really the explainability, which most of this discriminative model doesn't provide. Because
Mm-hmm.
in this case, I'm actually predicting the journey for the patient. I can
Yeah.
simulate the journey. I can,
Yeah.
and actually for each of these event which is happening, I can
Mm-hmm.
add a probabilistic value and actually tell him that this patient has a very likelihood of dropping off
Dropping off.
because of XYZ variable is coming out
Mm-hmm.
to be high
Mm-hmm.
or low in the
Mm-hmm.
design, right? So the level of explainability which can go is also another advantage of some of these architectures.
Very interesting. So in a solution like this, right, a couple of questions. One is, uh, normally, like you said, if you have to send a patient through a trial, it's 7 or 10 years. In a system like this, once you have a list of comorbidities and a list of values and things like that, and you say, I'm going to test this patient with this specific compound or drug, or can you accelerate the timeline? Like, what do you do to accelerate the timeline to say this patient? Like, what
Good.
do you do? Yeah,
No, that's a very good question. I will actually clarify one part on this.
yeah,
So
yeah.
when the trial happens, there are two
Mm,
scenarios.
mm,
There is test and control, and there is a
mm,
placebo which is given as part
mm,
of it. Now the patient doesn't know whether they have got the placebo part of
mm,
it. Now I just want to also emphasize it in trial.
mm,
All these models, generative
mm,
models, whether it's
mm,
clinical GAN or LLM, they are
mm,
still more and more in context learning. So what they have seen before, they can
mm,
project it.
mhm.
Whereas if I'm doing a trial on a drug, technically is a new event which
Yeah.
doesn't existed in the
Mhm,
history. So
mhm,
the patient
mhm,
whom I'm actually giving a drug,
yeah,
really not a placebo,
mhm,
I projecting their journey is
yeah,
not feasible by this architecture. However, the
uh-huh,
patient whom I'm actually going to give a placebo,
mhm,
that I can project. So the real that's why it's a digital patient. I
mhm,
I have given you a I have given you a drug, but I do
mhm.
have a placebo journey for you, and I can do
Right,
the comparison and see the effectiveness of the drug itself in this system.
right, right, right.
So it's
Makes
going to
sense.
reduce that size or
Mhm.
population size for the test group in this.
Understood, understood. And, just one follow-on question is, for a use case like this, right, when you're fine-tuning, how many instances of historical data do you need to fine-tune something like this to have a good degree of reliability on it? Is it in the order of hundreds or thousands or 10,000s?
Correct. So in for these, because the when you look at the patient level data in
Yeah,
a lot of these cases,
yeah.
I think even if you pick US like
Mm,
is one of the countries, the
yeah.
the collection
Mm,
is and centralization is very very good
mm,
overall. I
mm,
think country like India is still developing. I
yeah.
think that it's improving, but I think
Mhm,
it's still the capture is
mhm,
much lower as you see. So there are two
mhm.
kind of capture. There's a capture which is vertically, number of patients you're covering, and
Yeah.
then longitudinally, the journey
Right.
part of it.
Right.
So how well I'm capturing the longitudinal journey for my
Mhm,
patients in the
mhm,
system
mhm.
overall. So for these kind of models, because of the horizontal, even if it's a smaller, and that's where I think the time series
Ah,
play a very very big role. You get a lot of longitudinal journey.
makes sense.
It's very very easy to get a 6 year to 10 years kind of data sets for
Mhm,
these journeys, which
mhm,
can actually start feeding you, give a significant enrichment
mhm.
in the model.
Yeah. So the quality of the depth of each record instance is
Is
more
much
important
higher.
than the number of instances. Okay.
Exactly.
Yeah. Yeah. Um, this has been super helpful, Prakash, I know we're almost over time. Thank you so much for sharing your thoughts on this.
No,
It's
no,
very, very
thank you so much, Vinny, for inviting me. Thanks a lot.